Viewers, welcome to Senior Teleclass on Tech TV. I'm your regular host, Godfred Eduyeboa. Today, I'm here to take you through the introductory aspect of integrated science. Now, by the end of our lesson today, I want us to achieve the following objectives. That by the end of the lesson, a student, my viewers who are in the house, will be able to define what is called scientific methods. 2, identify the stages involved in conducting scientific methods. And 3, state 5 precautions to be observed at the science laboratory. Now, my wonderful listeners and viewers, let's take our time to go through the objectives that we have just listed above. Now, when you say scientific method, what comes into mind? It means the methods, the stages, the procedure by which scientists conduct their research work or how scientists work. So any means by which a scientist can just produce something that will be so meaningful, either to solve a problem or to produce something that will be so much beneficial to mankind. That one is called scientific methods. Now, scientists must go through a maximum of certain steps or methods before they can achieve their objectives. Now, let's look at these scientific methods. Now, the first point of call that any scientist will try to come out with a product or produce anything called identifying the problems. Now, when you say problem identification, what do you mean? A scientist will not just imagine that I have to just produce it and the scientist will just produce it. Before a scientist will produce something, that scientist might decide exactly what you want to do after careful observation. If you remember in the introductory aspect, we were saying that every scientist must have the ability to observe his or her environment. That is, your senses are supposed to work effectively with you. Your eyes, your nose, your ear, and even the skin. So therefore, for any scientist to produce anything or to come out with anything that will be beneficial in a practical way, first of all, there should be a proper identification. Now, what does it talk about? It means it talks about exactly what you want to do after careful observation. So recently, in that part of the world, here, we have what is called COVID-19, be the common disease. There is a problem. There has been identification. And therefore, scientists are supposed to decide exactly what they have to do. So one of the main methods is identification of a problem. Then you have number 2. For a scientist to perform an experiment, there should be an aim. Students who are watching me today, you know that for you as a student, you have an aim of what? Schooling. At the end of the day, some of you want to become medical doctors, engineers, lawyers, and the rest. So you have an aim. In a similar way, before a scientist can also produce anything, that scientist must have an aim of his or her experiment. So when you say the aim, you say this is the reason for your investigation. Example, to investigate the effect of area on pressure. Please, I want to set this example for you to just get the concept clear here. Let's assume that maybe you want to just compare the hairs of a shoe and that of, let's compare that of the female and the male one. The female one, because it has that kind of small pointed area, the moment they step, it's that kind of hair is able to get into the soil because the area of the hair is too small. And the pressure works is what's called area and at the same time. So therefore, if the area is too small, pressure is so much high. And if the area is too big, pressure is also what to minimize. So what we are saying is that with the aim, we state the reason for investigation. There is a COVID-19 outbreak. What are you investigating into? What causes that disease? What are the symptoms? Scientists are able to just conduct their investigation based on their aims, and they are able to come out with some precaution measures that we should put in place such that we can just overcome that kind of the spread of the disease called COVID-19. So before any scientist can perform the experiment, that scientist must have an aim. You are schooling. What is the aim of schooling? Become a medical doctor, become an engineer, become a pharmacist. In a similar way as you have that kind of aim, a scientist also set an aim before they conduct what is called a research work. Then you have number 3, formulate a hypothesis. Now what is hypothesis? It means it's a statement which you aim to prove or disprove by your investigation. I would ask this question. If there's an outbreak of disease, there's a need for us to conduct investigation to know the actual cause of that disease. Now, it could be that maybe we assume that disease is caused by a bacteria or a virus. So therefore, if you assume that it's a viral disease, then we should conduct investigation, study that kind of virus and identify to know that in this, this kind of virus that is caused that kind of disease. Or really, if at the end of the day, at the end of our investigation, we identify that kind of disease is not caused by a virus, then we may look out for another alternative that may be the actual cause of it. So in a similar way, when scientists want to conduct investigation, they have what called hypothesis. That's what I want to achieve. I have to either prove it or disprove it. Now, the process by which you can either prove that that disease exists or doesn't exist is said to be called the hypothesis. So here I have the example here. Pressure increases as what area decreases. If the area is too small, pressure increase. If the area is too big, then pressure decreases. So I was an example. Let's look at my shoe and the female shoe, where you have the pointed hairs. Because the pointed hairs have the small area, the moment you step down, it just stuck into the soil. But my shoe hardly would happen that way, unless maybe I move to what's called a muddy environment. So we are saying that pressure increases as area what decreases. Then we have another one called prepare and plan the investigation. For any scientific method to be well established and well known, you find out all that you know about the problem. Decide what you want to do and how to go about it. Let's give an example here. In the class that we are, assume that I have a problem with interscience. What can I do to overcome my interscience problem that I'm having? There's a need for me as a student to sit down and plan my life for. So therefore, I'll find out all the reasons. Is it because I don't like the science teacher, or because I don't read my note after teaching, or what is my actual problem? So if I'm able to identify that kind of problem, then I will know what to do. Am I supposed to go for an extra tuition or my timetable? Am I supposed to have an extra time for the science? So scientists, before they will just come out with the product, they have to plan and prepare in their investigation. So instead of find out all you can about the problem, decide what to do and how to go about it. This is one of the reasons or one of the stages that scientists must go through before they can come out with the product. We have point number 5. It's saying that experiment. Now I know my aim. I've identified the problem. I've set my hypothesis. Now I have planned. I must go to the lab for my experiment. What it implies before you go to the lab, then it means that all the materials that you may need. For example, maybe like if there's a COVID-19 outbreak and therefore I have to go to the lab for experiment, I must make sure that all the materials that I may need. For example, if I have to need blood sample, if I have to get maybe my sperm, if I have to get maybe saliva, or whatever that I think I may need to perform the experiment, scientists saying that as we go to the lab, when all materials are ready, then I'll go out there with the help of my microscope or other reagents that I may need and may carry out my experiment. See, carrying out practical work by observation and measurement. With our science, measurement is important. So like maybe in our next lesson or in our subsequent discussion, we'll study what's called measurement in totality. So a scientist will go to the lab, take a sample, measure it, and you know that this is the quantity I may need. Let me also give an example here. What are the science or in a science? If a scientist produce any product and they want to give that out to the human being or the human body, the first point of course is that they must measure the dosage. So that at least when they take in, it will not have any effect on the system. So any scientist that conduct experiment must be able to observe things well, that they begin to measure things accurately, so that the usage of it will not be overdosed or underdosed that may have serious repercussion on the user. Then you have the next one, saying what is called data collection. Now, if you are just my student here, I believe you are aware of what's actually happening in our country here, whereby there is an outbreak of what is called cerebrospinal meningitis. When you travel to the north, it is common over there. Now, what you have to look at here is that scientists are supposed to collect data. A day, how many people are we getting the infection with? Recently, we were told that one of our neighboring town, Obuasi, about a few days ago, there was a conduction to assess the number of students who are having this kind of COVID-19. And out of 1,003 people that the test was conducted, data that they had over there implies that out of the 1,003, 1,203 people were infected with that kind of disease. So a data collection will help the scientists to know how things are being going on. So we say collect and record data. Every place that you go to the lab, when you take a sample to perform the experiment, you record it. Some of them, you're not going to have the result within a day. And therefore, it's a gradual process. So you collect data and you record them so that you can make what is called inference out of your data. Then you have the point number 7. Point number 7 states that you have what is called data analysis. So after conducting the experiment, there's a need for us to go out there to do what is called analysis. We are supposed to explain each point. That maybe we notice that out of the people that we just gathered for the experiment, females, you have about almost 50 of them. males have about almost 70 of them, or we have even cases below the age of what is called 15, or below the age of 18, or below the age of 10. So therefore, it is tantamount to you as a scientist to explain and draw what is called deductions from the experiment. Now, after the experiment, we can say that indeed that disease is called by what is called a virus. Or after the experiment, we can say that maybe if the individual is able to distance him or herself from the neighboring, we can control that kind of disease. So it explains and draw conclusion or deduction from the experimental data and other sources in order to prove the hypothesis. Have it in mind that the hypothesis was there to either prove or disprove. So after experiment, is there anything to prove that indeed COVID-19 is caused by a virus or a bacteria, or cerebrospinal meningitis, maybe it's caused by as a result of what called dehydration, or maybe poor hygienic environment. So therefore, you are able to base on your analysis of the data to deduce whether indeed the disease exists or it doesn't exist. And you have the last but one thing that you have what is called conclusion. You know, after you have performed the experiment, you look at all the aspects of the investigation, make a brief statement on whether the hypothesis has been proved or disproved. I've done my investigation. Indeed, was the disease caused by a virus? Can I be boldly to say that that's why it caused it? Or maybe like my investigation didn't prove otherwise. So it is tantamount to you, after your systematic way of doing investigation, you do what's called conclusion to prove or to disprove whether your aims, the objectives that you identify in the above. And the last one that we have here state that if necessary, other useful things encountered and suggested for further experiment can be included in the conclusion. Scientists, you shouldn't be selfish. Do you have any suggestions so that maybe like because of time factor, you couldn't finish everything? There's a need for you as a scientist to create an avenue so that in the near future, other people can also continue from where you got to, and they can also draw a conclusion that will be so much beneficial to mankind. Because in science, our main motive is to produce things in a practical way that are so much beneficial to mankind. So, if important, things that we encountered, suggestions, all those things are supposed to be made available in the course of your experiment. So these are the stages you have to go through. And now, seriously, every aspiring science student must be what we call the curious. Curiosity kills the cat. If you are not curious, hardly can you be a scientist. Because it's as with the curiosity that you can establish your in and out, whether indeed your experiment, your works and everything can be so much good for you. Then having said this, as a scientist, as we go out to perform our various works, there are certain scientists that have been able to use the scientific method to conduct their investigation. And here today, viewers, we are going to look about almost 3 people who have used the scientific method here to conduct their own investigation. The first point of call that we look at here is a man that is how the individual was able to discover what's called penicillin. Now, it's that it was discovered in the year 1926 by a British bacteriologist called Alexander Fleming. Now, what actually happened here was that this man was able to use a bacteria called Staphylococcus or Staphylococcus bacteria to conduct his investigation. He was able to see that this kind of bacteria was being able to take care of by a certain penicillin when there was a wound on an individual. So it is discovered by scientists, or scientists are just proving that a chemical or a medicine called penicillin was discovered by a man by name Alexander Fleming. He was said to be a British. Then you have the next one called radioactivity. Now, it was also discovered in the year 1896 by Henry Becquerel, who was investigating the action of bright light and uranium salt on a photographic plate. Here, what this man was trying to discuss here was that he wanted to see how the effect of what is called sunlight will be what is called uranium. And it was through his work that he has something called radioactivity. It means the spontaneous disintegration of unstable nuclide to produce the alpha, beta, and gamma ray. Maybe in a subsequent lesson, we shall look at the radioactivity itself as a topic on its own. And the last person that we look at here is said to be called, that is Archimedes. He looked at what is called flotation. And like Archimedes is regarded as one of the greatest scientists of all times. And like he was able to deduce how a ship, as big as it is, it can float on the water body. But when you throw a stone into water, that stone will just sink. And according to Archimedes, on the principle of flotation, he said that when the body is partially or fully immersed in the fluid, it experiences an upthrust, which is equal to the weight of the volume displayed by the body. Maybe as time goes, we shall look at that one properly under what is called force, pressure, emotion. We shall look at what is called flotation itself well. So it's Archimedes who was able to deduce how ship, big as it is, can just float, but a stone can just sink in a given water body. Then, having said that, he's considered to be a pioneer of experimental science because he was interested in carrying out experiments to explain and prove scientific theories. He is considered to be the pioneer of experimental science. So what you're even going through, it can also be deduced that he was the one who even established that kind of systematic way of conducting scientific experiments. And as I've just told you, he discovered how a ship can just float, but a stone, when thrown into water body, can just sink. Then, having said about this scientific people who use that kind of scientific method to produce things that are beneficial to mankind in a more practical way. As scientists, when you work at the lab, there are certain safety precautions that you should observe at the lab. Now, when I say safety precautions, what are you trying to imply here? It will mean the do's and the don'ts at the lab. I know some of you, my students here, sometimes, as I said, curiosity kills the cat. When you get to the lab, you want everybody to start. In fact, I'm in the lab. You begin to touch things here and there. But please, when you get to the lab, there are certain precautions that is just observed. So we shall take our time to go through to see those things that we are supposed to do at the lab and what not to do at the lab. So when we say the safety precautions, we are saying that when you get to the lab and you are going there for any experiment, you must wear what is called laboratory coat and shoes to protect your body and the foot. That one is there. It's a wear laboratory coat and a shoe. Why am I supposed to put on that laboratory coat and the shoe? Just to protect your body. Because in the course of performing experiments, it is possible that a liquid may splash and get into your contact and get into the body. Have it in mind that some of this liquid are said to be corrosive and they can cause even burns to the human body. So the moment you have what is called the coat on, the coat will protect your skin so that you're not going to have any contact with that kind of splash that may come from the liquid or other things that may have the lab. Again, too, an object may fall from a height. It can be maybe a chisel, it can be a hammer, and the rest. If the foot is not protected, have it in mind that that individual can get injured. So we wear the laboratory coat and the shoe to protect our body and at the same time our foot too. Then let's look at the next one they have there. Do not taste, eat, or drink in the laboratory unless your teacher says it is safe. Please, the lab is not dining hall. Students, whereby you go there and eat. At the same time too, you're not supposed to go there and drink anything from the lab. Because sometimes if you don't take care, you may take an acid. Please, acid too is very corrosive. And therefore, the moment it gets into your body, it can cause burns. So do not eat. Don't go there with the food because when you get to the lab and have the food, it implies that some of the chemicals can get contaminated with the food. And the moment you take that kind of food into your system, it is likely that you are going to have what is called an infection, either around stomach, as people call it, or again, to sometimes you can even have some kind of irritation on the human skin. So please, do not eat, drink, or eat in the lab unless you are told that it is safe. Then number 3, wear protective goggles or use a protective shield to protect your eye and body from hazards such as dangerous splashes and explosions. Maybe let's assume that I'm a technical student, I'm using what is called metals, or I'm working with metals. I need to cut them. I need to join some kind of joint with the metals. Please, there will be some kind of splash, and therefore I must put what is called the goggle to protect my eye. Because if those kind of particles from the metal should get into the corner of my eye, there can be a cut to the human body. And therefore, there's a need for me as an individual to wear the goggles to protect my eye. Again, too, you have to make sure that those goggles are supposed to just prevent splashes of other liquid that can get into contact with the human body and again to explosions. So this is supposed to be put on when you get to the lab. Then number 4, we are saying that avoid splashing liquid or cracking the test tube. Come again, you have to sway the liquid repeatedly in and out of a hot part of a flaming to spread heat. Let's assume that I'm in the lab. I'm heating a liquid in the test tube. So I assume that I have this one here as my test tube, and I'm supposed to apply heat to it. Please have it in mind that I'm not supposed to apply the heat to just only one point. But in the course of applying the heat, I must sway. When I say the sway, it means that the test tube must be turned where we have the source of fire or the heat. As you continue to turn it, it will help the heat to get distributed along the whole liquid or the whole container. Because the moment you are trying to apply the heat to just one side, that place can get overheated. and therefore there can be cracks, which can lead to what is called accident at the lab. So we are saying that in order for the flame to get distributed, you must just sway it so that at least the heat content that we have there can get distributed in the entire test tube for your experiment to be well conducted. Then number 4, we have said that when heating the test tube, do not point the mouth of the test tube towards yourself or another person. This is a dangerous act, my student. If you are heating the test tube and try to point the mouth of the test tube to yourself or your colleague, if that kind of test tube should get overheated, it is possible that it can get exploded, and therefore that kind of liquid can just splash to yourself or to your other colleague. So when you are heating the test tube, the mouth of the test tube should just point up into the atmosphere, neither to yourself nor to your other colleague who is just so close to you. Then we have the next one that we have there. See, when possible, heat inflammable substances in a water bath to minimize direct contact of the flammable vapor with the fire source. When you say flammable substance, what are you trying to imply here? They are those things that can easily catch fire. So let's assume that maybe in the lab, I want to test for starch in the leaf. In the course of testing for starch in the leaf, at a certain point in time, you are supposed to place the leaf in alcohol. Then you heat the alcohol on water bath. Please, alcohol is what? Highly inflammable. The moment alcohol gets into contact with fire, there can be a fire outbreak. So therefore, when you have second of maybe substance that I said because highly inflammable, don't heat the alcohol on naked fire, but in what is called water bath. When you say water bath, doesn't mean you're bathing yourself. But when you say water bath, it means what? Boiling water. So that at least the alcohol that you have there or those flammable substances may not get into contact with the fire and result in what is called fire outbreak at the lab. Then you have the next point there, saying that use a test tube holder, tongs or soft cloth to hold hot things where possible. Please, at the lab, you are not supposed to use your naked hand to pick hot objects. We have a device called test tube holder. As time goes on, I get to know of it, or something called the tongue, just to hold hot objects. Please, the moment you use your hand to pick that kind of hot object, you may not continue to hold it up. You may just drop it, and it can be a splash which can cause an accident to your colleague or yourself. So please, in as much as possible, my student, don't go to the lab when hitting a hot object and begin to use your hand just to pick it, because there can be an accident either to yourself or to your colleague that you are just studying your science with him or her at the lab. Then you have the next one, say that follow instructions carefully and do not carry out any experiment without the knowledge of your teacher. Student, I know some of you, when you get to the lab, you want to have access to every material you have there. You touch this one here and there. But please, follow instructions. With your chemistry class, when you perform maybe titration, you will tell that maybe pour the acid into the burette, pipette 25 cm cube, maybe the base, into the conical flask. It is an instruction given to you by your teacher. And under no circumstances are you supposed to perform any experiment in the lab without the consent of your teacher. When you do that, it is possible that you can cause an accident at the lab. So please, follow instructions before you can perform an experiment at the lab. Then you have the next one, say, always add acid to water, not water to acid. That point, let me take again. Say, always add acid to water, not water to acid. Say, this enables the heavy acid to fall to the bottom of the container, and the process mix well to spread heat formed to avoid boiling. You know, acid is very corrosive. And please, if somebody decides to pour an acid on you, run for your life. And therefore, if you try to add water to an acid, there's a need that there will be a heat which will be generated because water is being added to acid. But when you add acid to water, it will be in a systematic way because the acid is heavy. It will get to the bottom of the container, then the heat will be distributed, such that there wouldn't be any fire outbreak at the lab. But if you do it in the opposite direction, then please have it in mind that at the lab, you want to set the entire science lab ablaze. So please be very careful that you don't add water to acid, but rather acid to water for the heat component to get well distributed in the test tube that you are using for the experiment. And now the next one, which said that as a scientist, do not work in the broken glasswares or sharp-edged metals. Some of you, when you get to the lab, the test tube that you're using over there may be broken. It is possible that it can cut you, and therefore there will be an injury at the lab. So when you go there, make sure that if you are asked to go and perform an experiment, the tools that you are going to work with, they are all said to be in good shape before you use them at the lab. Don't go out there and work with sharp objects when you're not well protected. For example, a chisel can just cut you just like that. Okay, sometimes a knife can just cut you just like that. So a saw can be cut just like that. So please make sure that things that I'm working with are where are said to be in good condition before probably you use them to work at the lab. Then you have the last but one, do not take fire to an inflammable substance or vice versa. Please, when there's a kerosene there, when there's a petrol there, don't take up a lighted matches or whatever to it. Because the moment you do that, then it means I want to set the whole science lab ablaze. So please, do not take a fire to an inflammable substances or vice versa. Then you have what is called accident and breakages must be reported to your teacher or technician. When you go there and there's an accident, if an acid should pour on you, please report to your teacher or technician. If you go there and you break a test tube or a conical flask or whatever they're going to break over there, please make sure that you report to your teacher or technician for the immediate action to be taken. Then we are saying that any chemical spilled on the body must be rinsed well with plenty of water and then reported immediately to your teacher or technician. Please, when a liquid should pour on you, use a lot of water to wash that part of the human body. Don't allow the liquid to get stuck into the human body because some of the ones I told you may be corrosive. They can cause burn to the human skin. So therefore, you wash it with plenty of water, then report it immediately to your teacher or the technician. Then you have the next one saying that after carrying out experiment, wash the apparatus, work surface, and clean your hands before leaving the experiment, leaving the laboratory. Please, I'm asking this question. In the house, after eating, do you leave your cooking utensils there or you wash them? In a similar way, in as much as the lab is not a dining hall, after working, please wash the apparatus. Test tube was used, a conical flask was used, a funnel was used. Now, after everything, wash it so nicely, then you clean the working place before you leave the laboratory. Then you have the last, but one of the least, that make sure you know about the basic safeties and hazard signs. When you get to the lab, you'll be told that you have the goggles to put on, gloves to be worn. Now, these things that you have there, you should know them, so that when you get to the lab, there wouldn't be any much problem for you as a student. Now, students, this is where we want to draw the curtains to our discussion for today. Last one is that do not smell an unknown gas with nose very close to the test tube containing the gas. Some of this kind of gas may be choking, may be irritating, may be pungent. And therefore, the moment you bring them so close to the nose, it can cause that kind of irritating, which can cause an air health to you. Let's assume that maybe I'm an asthmatic patient, and I go to the lab, and I begin to take in or inhale gases that I don't know anything about it. Then have it in mind that I want to just aggravate things for myself. I'm an asthmatic patient, I'll not be asked to take that kind of gas just close to my nose, and I've done that. The moment it's happening that way, then you are going to put yourself into trouble. So these are some of the precautions I want to just see. And the last one is that always prepare poisonous gas with fume chamber. When it comes to our lab, we have a special device called the fume chamber. This is where we prepare most gases. You cannot just go to the lab there and prepare any gas anywhere. There should be a special place where this kind of poisonous gas can just prepare for you to be on the safer side. Now, we are trying to bring our discussion to an end. And I want us to look at the summary, what we have gone through today for our lesson. Now today, my viewers and students there, I know that when you are asked to define what is called scientific method, you will know that is the ways by which scientists would conduct their experiment or scientists work. Then, again, that you have steps that are involved in the scientific method. These steps are: 1, identifying problem; 2, stating the aims; 3, formulation of a hypothesis; 4, prepare and plan your investigation. We have 5. 5, we have the experimentation. We have 6, we have data collection. We have 7, analysis of data. We have 8, conclusion of the experiment. Now, these are the discussion that we have gone through. Again, we have some safety precautions that we have just discussed here. That at the lab, safety is very important. And therefore, you must wear your laboratory coat and shoes to protect your body and the foot. Again, you must make sure that when heating, wear laboratory coat. Then again, when heating a test tube, do not point the mouth to the test tube towards yourself or another person. Then we are saying that this is where we are going to end our discussion today. I hope that you really enjoyed the lesson. And I believe in our next meeting, we are going to introduce to you a new topic which is more interesting and captivating. Till we meet next time, may the good Lord be with us all.